Experimental performance analysis on K-means clustering technique. First question. Select the required input columns from the dataset. Uh, the task is to import the necessary libraries and load the dataset. So we have imported the necessary libraries here. Then pandas for handling tabular data, numpy, numpy for numerical operations, and math plot library. So for this is for visualizing data. K means K means clustering algorithm from scikit-learn, and so this line. So here, it defines the column names manually since the data file wdbc.data has no header. So we define the column names here. Manually, we define the column names. And here, select only required input columns. Loads the dataset into data frame called data using the column names and define. It is defined. It is defined here. So radius mean, texture mean. It selects only two columns that will be used for k-means clustering, and df.head it displays the first 5 rows to verify data loading. Second question. Second question is to display the top 10 rows of the data set. So I have printed my URL, and the df.head. The df.head it is the first 10 rows of the data from df. So here we got the output. Third question. Check the null values before applying clusters. So before applying clustering, you must check if there are any missing null values of the data that could affect calculation. So firstly, I have printed my URL. Then df is null. Here df dot is null. It returns a Boolean table where true equal to missing value. So dot sum. Dot sum means it counts how many missing values are in each column. It counts the null values of each column, and this shows whether you need to handle fill or remove missing data. And it means we have to fill or remove the missing data. So then, fourth question. Fill missing values with the mean of respective columns. The question means if there are missing values, they should be filled with the mean of that column so that the clustering can work properly. So firstly, I have printed my URL and the df mean. df mean, it calculates the mean for each numeric column. df.fill now it replaces missing values with those mean values. So df df filled. So it creates a new data frame df filled with no null values. So before filling null values, before filling nulls, so this shows null count before filling, and this shows null count after filling. Here we have before filling. Here we have after filling. Fifth question. Plot graph between number of clusters K and WCSS. The question means so here we must determine how many clusters are ideal. The elbow method, it helps to decide this by plotting K versus WCSS. What does WCSS mean? So WCSS is within cluster sum of squares. Within cluster sum of squares. So here I have printed my URL. WCSS. So here WCSS, it lists to store within cluster sum of squares for each k value, and range is 1, 11. What does the range mean? It tries to cluster sizes from 1 to 10. So here we have the loop statement. It loops through each k value and it tries clustering model. And this line represents how far points are from the cluster center. The distance between the points from cluster center to the points, the distance between them is represent this line. So then, yeah, that's it. So here plots the elbow curve. Here we look for bend or elbow in the line that points the best K value. So yeah, here is the output. Sixth question. Select the optimal K. The question means after observing the elbow method plot, this plot, after observing the elbow method plot, choose the best number of cluster for you for your data set. So we have to choose the best number of cluster according to our data set. So I have printed my URK here and this line optimal k equal to 3. So here manually it selects the best k value based on the elbow graph. Based on this elbow graph, we select the best k value manually and print. Now it displays the chosen value for later use. And seventh question. Seventh question is to perform k means clustering with selected k with selected k. This means first I have printed my URK and K means optimal. This means it creates a K means model with the previously chosen number of clusters. And the N cluster equal to optimal K. Number of clusters to form. This is said to be number of clusters to form and random state equal to 42. This is said to be it ensures the same result every time. Every time it runs, it ensures the same result. So DF filled fit where was it? Fit predict. Fit predict it both fit predict both fits the model to the data. It assigns cluster labels to each row. So then we are printing. So it confirms the process completed successfully and displays the chosen K value. Eighth question. Eighth question, display cluster centroids. So I have printed my values. See, I have printed my URK. And the centroids equal to K means optimal dot cluster center. So it retrieves the coordinates of the cluster center. For example, if radius mean and texture mean are two features, each row in centroids will show one cluster center. So then print cluster centroids. This means it prints a label before displaying the actual values and prints centroids. It displays the numeric centroid values for each cluster. So ninth question, we have to visualize the cluster. I have printed my URK. PLD.figure fixed size. So it creates a figure of width 8 inches and height 6 inches. It is good for clear viewing. Plot class scatter. So here, okay. It plots each data point using its radius, mean, and texture. Using its radius, mean, and texture, and C equal to DF filled cluster. So it colors points according to which cluster they belong to, and C map uh, and C map. So what does C map does? It uses a visual clear color gradient, and S is equal to T. It sets the size of each point. So here plot X label, radius mean, and plot Y label texture mean. It labels the axis so viewer knows what each dimension represents. So then plot dot legend, it displays the label for each centroid on the graph, and plot dot show finally renders and displays the static plot. And here is the output. Thank you.